Welcome to Study Loop.
This is a fairly involved problem, where we are taking a look at how we can use the quadratic formula to solve an equilibrium type of problem. We have two equivalents of IBR in equilibrium with I2 and BR2. We're going to start off with an ICE table, which stands for Initial, Change, and Equilibrium Conditions. We are told we start off with 0.025 atmospheres of IBR. According to the stoichiometry then, we must lose two equivalents of IBR, shown by the two here, and we gain one equivalent each of I2 and BR2. Therefore, at equilibrium, we have 0.025 minus 2x IBR, and we have x I2 and x BR2. Kp is products over reactants, so that's the pressure of I2 times the pressure of BR2 over the pressure of IBR squared, because of the 2 as its stoichiometric coefficient. We can now plug in what we know. We have two x's in the numerator, so that's x squared, one each for I2 and BR2. And the denominator is 0.025 minus 2x, and that entire quantity is squared. Additionally, we know what Kp is. Kp is a number, 8.5 times 10 to the minus 3. So now we're going to multiply over this denominator, as well as FOIL it out, since we have to square it by itself. So x squared, do this one step at a time. If you FOIL out the denominator, you have x squared over 6.25 times 10 to the minus 4th minus 0.1x plus 4x squared. And again, that just comes from taking the square here. Okay, now I'm going to rewrite this bottom equation over on the top right, but I'm going to take this entire bottom portion and multiply it over to the right side. So on the left, we now just have x squared and we now have (0.034) x squared, so that's that last term, 4x squared times 8.5 times 10 to the minus 3. Minus 8.5 times 10 to the minus 4x. That's the middle term here, multiplied over by Kp. And finally, we have 5.31 times 10 to the minus 6 is our last term here on the left, multiplied by 8.5 times 10 to the minus 3. We are now going to set the expression equal to 0. So let's collect our two x squared terms together. We get 0.966x squared by subtracting over the 0.034x squared from the 1x squared. We add our x term to the other side, plus 8.5 times 10 to the minus 4x. And we subtract our constant, minus 5.31 times 10 to the minus 6. All so that we can set this equal to 0. Now we can employ the quadratic equation, x equals negative b, plus and minus the square root of b squared minus 4ac all over 2a. A, b, and c are the terms in front of x squared, x, and this last number here, respectively. So x equals negative 8.5 times 10 to the minus 4. So that's negative b. And next, I should write plus or minus. However, it's worth remembering that we need our concentration to come out as positive, and we're starting with a negative number here. So if we wrote minus, there would be no way for us to get a positive concentration. So we are only going to take the positive root. So negative 8.5 times 10 to the minus 4th plus the square root of b squared minus 4 times a times c, remember the negative sign, all over 2a. So that's a lengthy expression, but if you type it into your calculator, you get x equals 0.0019 atmospheres. And because we know our equilibrium concentrations of I2 and Br2 are just x, that equals the pressure of I2 and the pressure of Br2 at equilibrium. To find our last pressure, P of IBR equals 0.025 minus 2x. So using the x that we just calculated above of 0.0019 atmospheres, multiply that by 2 and then subtract that from 0.025. And you will get its pressure to be 0.021 atmospheres.